Welcome to this lecture video, Salting and Disk Scheduling Algorithm. In the unit 5, discussing input I/O system in the operating system. In the Salting and Disk Scheduling Algorithm, SSTF is a common and has a natural appeal. C-scan and C-scan perform better for a system that places a heavy load on the disk. Performance depends on the number and types of requests. So requests for disk service can be influenced by the file allocation method. So disk scheduling algorithm should be written as a separate module of the operating system, allowing it to be replaced with a different algorithm if necessary. So either SSTF or look reasonable choice for the default algorithm. Then disk management, important concept is the disk management. So it is a low-level formatting, a physical formatting, dividing a disk into a sectors that the disk controller can read and write. To use the disk to hold files, the operating system still needs to record its own data structure on the disk. So partition the disk into one or more groups of cylinders. So logical formatting and making a file system. Boot block initialized system. The bootstrap is stored in a ROM. Bootstrap loader program. Methods such as sectors pairing used to handle bad blocks. So disk management, these kind of things. MS-DOS disk layout, sector 0 and 1. Boot block, FAT, root directory, data blocks and subdirectories. So swap space management is a virtual memory. Use the disk space as an extension of a main memory. Swap size can be curved out of a normal file system. One or more, commonly it can be in a separate disk partition. Swap space management 4.3 BSD allocates swap space when process starts hold text segment and data segment. Kernel uses swap mesh to track swap space uses. So solarizes to allocate swap spaces only when a page is forced out of physical memory, not when the virtual memory page is first created. So swap space management, we have these kind of things. Then is BSD text management, swap 512 MB, 512 KB will be contained with major things in the text swap management. So in this we have the data segment. Map can be 16K, 32K, 64K and other 128K. So 256K will be a data segment swap. Then RAID structure will be a RAID multiple disk drives provides reliability via redundancy. So RAID is arranged into 6 different levels. In the RAID, several important improvements in the disk uses techniques involve the use of multiple disks working cooperatively. Disk striping uses a group of disks as one storage unit. So RAID scheme improves performance and improves the reliability of the storage system by storing redundant data. So mirror or shadowing keep duplicate of each disk. Then clock interval parity uses much less redundancy. Then we having the redundancy things followed with RAID 1 mirror task, RAID 2 memory, RAID 3 bit interval party, block 4 interval party, then block 5 interval distributed parity, RAID 6 plus P plus Q redundancy. Then 0 plus 1 and 1 plus 0 we have stripe mirror, RAID 0 plus 1 with a single disk failure, stripe with mirror, RAID 1 plus 0 with a single disk failure. So we have the mirror and mirror, we have the stripe X and Y, RAID 0 plus 1 with cases here. So disk attachment may be attached one of the two ways. Host attachment via input or output port, network attachment via network connection. So disk attachment helping these disk to host attachment and network attached via network things. Then network attached storage. In this picture we can able to see the LAN man contained with the NAS and NAS with different clients. So LAN man helping the network attached storage is network attached storage the NAS. We contained with the LAN local area network or wide area network. In the networks helping the different network attached storage will be splitting the data and process to the different clients, client 1, client 2, client 3 up to n number of clients attached to the local area network. We have the NAS, it's a network attached storage here. So in this picture we can able to see how the network attached storage are performing in the I/O systems. In the disk storage, mainly in the mass storage and disk scheduling, disk storage process. Then storage area network is a SCAN. Next, compared to the storage area network, is SAN. SAN is nothing but the storage network connected with the RAID data server, tape library, server, LAN and WAN client with the data processing center and web content provider. So SAN we have the server things, RAID data server, tape library and other things. So this storage area network connected to the data processing center, web content provider to follow the things. Thanks for watching. We can see the disk scheduling and storage scheduling and other topic in the next video. Thanks for watching. Thank you all.